Hey guys, welcome back. We are talking about soil formation and erosion. This is 4.2. Here are our learning objectives. We're going to understand what soil is and its role in the environment, understand parent material, climate, topography, and biological factors in soil formation, understand soil horizons and how soils layer out, understand how soils can be eroded, review the effects of erosion on water quality, and discuss methods to protect soils from eroding into water. So here's what you need to know about soil. Soil is a combination of organic and inorganic materials. Those inorganic materials largely come from rock matter. The organic materials are going to come from things like plants and other little critters that are living in that soil and the decomposition of both of those things. The combination of those contribute to what makes up soil. Soil makes up a really large portion of the Earth's surface, which is good for us because this is where our producers grow, and they are the source of all of our consumable energy. So that's really important for us. So it's really important that we have viable soil or nutrient-rich soil. The biggest problem with soil is that it's non-renewable. It takes tens of thousands of years to develop. So once we ruin soil, we overuse it, we overharvest in soil, we deplete it of all of its nutrients, that soil isn't coming back within a human's lifespan. It's going to take hundreds of thousands of years depending on, or tens of thousands of years depending on how depleted that soil is of everything for it to come back and become viable and grow and support living things again. So we'll talk more about that in our agriculture unit, how humans really deplete soil quality. In this unit, we're more going to focus on, composition of soil and how we define it. Now, soil science is really looking at this sequence of events. It's looking at how we take rock that just like a rock on the ground, and over the course of weathering and erosion form something that more resembles soil, and then from there how that soil becomes even more mature and develops very specific layers to it that we are the most familiar with. We've actually already talked a little bit about soil formation when we talked about primary succession. So if you think back to Unit 2 when we learned about primary succession, this was when we first said all we have is rock material. And through the process of decomposition of lichens and the erosion of rock material through wind or even things like acids being released from the decomposition of lichens, we start to form something that is more resembling of soil, and we start to see that progression of succession occur. So that's our knowledge of soil so far. But let's take another look at weathering and erosion. So these are two different ways in which rock material can be broken down. Weathering has two subcategories, physical and chemical, and then erosion is only one, but is more of a physical type of weathering. It's very similar to physical weathering with one exception. And so both of these allow rock material to break down and form something that is more resemblant of soil, and the really big part of that is we're releasing those stored nutrients within the rock material. We talked about this already as well when we learned about the phosphorus cycle. So remember, phosphate ions are often stored within rock material. In order for those phosphate ions to be released, things like weathering and erosion have to occur. And remember, phosphate ions, or phosphorus, is a really important component or a really important macronutrient required for plant growth. It's often a limiting nutrient. So weathering and erosion are really important to creating a very nutrient-rich soil. Let's talk about physical weathering first. So physical weathering is the mechanical breakdown of rock into smaller pieces. And this is probably the most straightforward one. Physical weathering can be caused by either water, wind, temperature changes. Essentially, all you need is a small crack in your rock. And as wind passes through, as water passes through, as temperature variations occur and that crack expands, or maybe it cools and it goes from its expanded state to its much smaller condensed state, all of that is going to contribute to physical weathering. So you can imagine, like in image A, this probably started as a small crack, and years of water passing through, wind passing through, variations in temperature, we've created a much larger sort of gap in this rock. But imagine how much time that takes. So again, soil formation takes a really long time. Imagine how long it would really take using those types of methods to break this rock down into something that more resembles soil. We tend to see physical weathering happening or being more likely on rocks that have a much coarser outside. So I'm sure you've picked up a rock and you felt the outside and it is more grainy versus like a very smooth stone. Rocks that have that grainier texture are far more susceptible to catching water or wind, and so they're more likely to undergo physical weathering or more quickly be affected more quickly by physical weathering. Now, chemical weathering, this is going to be the breakdown of rocks and minerals by chemical reactions or the dissolving of chemical elements from rocks. It could be one or the other or both. Undergoing chemical weathering will essentially provide the same thing that physical weathering will, which is the release of nutrients from the rocks into some sort of soil so that they can then become accessible to plants. One type of chemical weathering that we've already talked about are those lichens, which produce a weak acid as they undergo decomposition. That acid that's being released from the lichens helps to chemically weather the outside of that rock and break it down and release those nutrients like phosphate ions. Other things that you may be familiar with are things like acid rain. So sulfur dioxide is something that's commonly released as a result of burning things like fossil fuels such as coal. When sulfur dioxide gets released in the air, it undergoes a chemical transformation and becomes sulfuric acid as it interacts with gaseous water vapor. That sulfuric acid then accumulates as a particulate and falls when we receive heavy amounts of rainfall. You've probably heard of acid rain or acid precipitation before. Depending on how low the pH is, that can have an effect on rocks as well, especially depending on the quantity that it's interacting with. So that's chemical weathering. And the third one here is erosion. And so erosion, like I said, is very similar to physical weathering in that it is a physical removal of rock fragments. But this is more specific. It's from a landscape or an ecosystem, and it's removing them so much so that they're actually traveling a very certain distance away from their original source, and they're going to accumulate elsewhere, so outside of that original landscape or ecosystem. And so they're traveling this very specific distance, and they're going to end up as a deposition somewhere. That's the term. And so erosion takes a set of nutrients away from an ecosystem or away from a landscape, whereas physical or chemical weathering, even though the nutrients are being broken apart from that rock material, they're still ending up within that ecosystem and contributing to the soil. Erosion, they're being removed from the ecosystem and being placed somewhere else, leaving that particular ecosystem without the nutrients that would come from those rocks or the minerals that would come from those rocks. And so oftentimes with this, a big contributor is going to be wind, water, ice, or even the topography of the area if you're somewhere on like a slope. And so when materials get carried away because of heavy amounts of wind or water, that leaves that area without the ability to form a nutrient-rich soil. Okay, so we already know soil formation happens over time because we've learned about primary succession and secondary succession. We know that it starts with this parent rock material that either gets weathered or fragmented in some way or eroded in some way and eventually starts to resemble something that looks more like soil, especially as we start to have more living things there. But what do we know? How can we determine more specific properties of that soil? And so there's a few categories, 5 categories that we look at specifically as we're trying to define soil. And so the first is the parent rock material. Next is the amount of time it's been forming, the climate it was formed in, the abiotic and biotic components of that particular ecosystem, as well as the topography. And I'm going to expand on all of these. So first, parent rock material. So parent rock material, we already said, is that original rock that gets broken down by either physical or chemical weathering or erosion, and it provides the inorganic portion of soil. Remember, soil is composed of both organic and inorganic components, and the inorganic components come from this parent rock material. Now, depending on the parent rock material that you start with, that's going to depict the type of nutrients that are found within the soil. So certain types of rock will contain more of certain types of minerals than other things. Some are really high in things like calcium or phosphorus. Those are going to end up being really nutrient-rich soils, or things that contain high amounts of iron, magnesium, calcium. Again, those are going to provide really nutrient-rich soils. If you have a parent rock that doesn't contain a lot of minerals or nutrients to it, you're going to end up with a relatively nutrient-poor soil. Even if you have the organic component, you need both the organic and inorganic component to form that really fertile soil. The next one is just time. We already said soil takes time to form. And this is one of our biggest problems in agriculture today, is nutrient depletion of soil and not having the ability to return those nutrients fast enough in order to continually grow food. So we know it's really a problem that we have all of this land that's no longer usable for farming, because we've sort of turned it into nothing more than a dust. Okay. The next one is climate. Climate plays a pretty big role, and it's not just temperature. We're also talking about things like precipitation, or the amount of precipitation an area receives annually. We already know in our biomes unit that the soil, we learned that the soil in areas like tundras, because it has permafrost, there's very low levels of decomposition. When we don't see high levels of decomposition, we don't see nutrients being returned back to the soil. And so as a result, we end up with really nutrient poor soil. We also learned in our biomes unit that even though tropical rainforests, or areas that are humid tropics, have tons and tons of biodiversity, they actually have some of the most nutrient poor soils. And that's largely because most of those nutrients are being used by primary producers in that area. They're basically taking all of the nutrients out of the soil just as fast as they're being returned, because there's so many living things. Additionally, you have a high amount of rainfall in that area, a lot of water running through that topsoil layer. Any nutrients that are sitting on the top as a result of recent decomposition are really just going to run off with the soil. So climate plays a pretty big role. This is something we're learning about in our eco-columns, but the role of organisms in soil. Not only are there detritivores or decomposers that break down dead or decaying matter and return the nutrients back to the soil, but they can also help to turn the soil over. So you guys added earthworms to your soil to try to keep it from compacting, give the roots space to grow, and move nutrients around so that every one of your seeds has equal access. They help to break down that detritus, that's that partially decomposed organic layer, and they release those minerals that were stored in living things and keep them back into, or return them back into the soil so they can be used for more living things. And then the last one here is going to be topography. This is the actual slope of the surface slope of an arrangement of a landscape. So if you are looking at soil formation that's happening on the side of a mountain, you may notice that the soil on the side of the mountain is going to be relatively nutrient poor, because especially if it's in an area that has heavy wind, heavy rainfall, heavy snowfall or snow melt, it's susceptible to things like landslides. All of that, all of the nutrients that are existing on the side of that mountain generally will end up at the bottom, and you're going to have this collection of very nutrient-rich soil at the bottom side, at the bottom of your mountain. So all of those properties then lead to something called a soil profile, or more commonly known as a soil horizon. And horizon is just another word for layers, so soil layers. There are 4 layers that we'll learn about in this class, and that's the O, A, B, C layers. I don't know why those are the names of, or the letters that are associated with each layer. They don't really make sense based on what's happening in each layer. But if you're looking for a mnemonic to remember them, I always use the mnemonic O, a bug crawled. I don't know if that helps you, but you're more than welcome to use it. The first layer, the O layer, is really easy to remember. It's the organic layer. So that one actually does correlate to the O. But this is where we see the most amount of living things occurring or living. So we've got a lot of plant growth, we have insects, we see various stages of decomposition. Could be early decomposition, could be late decomposition. But that's going to be the portion of, or the top layer of soil that we mostly interact with as humans. Toward the bottom half of the O layer, we also have something called the humus layer, which isn't in this actual description, but humus is the bottom half of the O horizon, and it contains the most fully decomposed organic matter. So as decomposition occurs, it moves more towards the bottom half of the O layer. That then works into the A layer, and this is going to be considered the topsoil layer. This is going to have a pretty even mix of the organic material as well as the minerals or nutrients that have come from the parent rock. And so this is where the bulk of plant growth is going to happen. So this is where plant roots are going to dig in, and they're going to have access to all of the nutrients that they need in order to grow. And so you can kind of see the root systems making their way down into the A layer. The B layer is going to have almost no organic material and is going to primarily have inorganic minerals or nutrients that came from the parent rock material. So you will still see rooted vegetation making its way into this layer if it needs access to a higher supply of minerals or nutrients coming from the parent rock. And then just below the subsoil layer is going to be the C layer, or the parent rock material. This is going to be the least weathered layer. You can kind of see what it looks like here. It's primarily going to have just minerals, but most of those minerals will make their way to the subsoil because they will have already been weathered. And so for the most part, or because they already would have been released from the parent rock, this is just sort of what's remaining that didn't get weathered. So there isn't going to be really much down here, and that's going to make up the C layer. So this is just kind of a roadmap of where we're heading for this unit. So we said we start with rocks and minerals within rocks, and we get those from the rock cycle. This may be something that we review in class together, although it would be just that review. Those rocks then undergo weathering, either physical or chemical, or they may undergo erosion, and that, coupled with the biosphere, the atmosphere, the hydrosphere, and time, are going to lead to the formation of soil. We are going to talk about conservation of soil, salinization, and erosion even further when we get, again, to our agricultural unit. We touched on it a little bit, but more to come. And then from there, once soil is developed, we know that it forms really distinct layers, or what we call horizons. And those horizons are largely going to be depicted by what the original parent rock material was, and then those other 5 properties we talked about: the abiotic conditions, time, climate, etc. Now, this other portion of the diagram, the porosity, the particle size, this is going to be actually classifying soil as a specific type of soil. This is what we're learning about next. This is 4.3, so stay tuned for that. And then this is also part of 4.3, that is the cation exchange capacity, and again will contribute to a property of soil. But I think that's it for today. So let me know if you have questions, and I'll see you in class. Thanks, guys.